Okay, we've talked about energy. Now I want to take it one step further. We want to talk about heat and temperature. This is where a lot of struggle comes in. People think that temperature is the measure of heat. It is not. Heat is how much energy is transferred between two systems. And so you can take energy, such as a flame burning on a stove, and you can transfer it into the pot of water, okay? And will the temperature go up? Yes. But heat and temperature are related, but they're not exactly related the way you think. Temperature is a measurement or a measure of the kinetic energy. And that means it is measuring the speed or the molecule motion, okay? It's how fast the molecules are moving around. And I want to take you to an idea which you don't understand. So we're talking about this idea even more in the future. It's called specific heat. Let's say we have an ocean, and then we have a nice beach that we are laying on. Or you're parking your car, and here's our water. So we have two materials. The sun has been shining on both the beach and the water all day long. So energy has been transferred. There is heat coming out of the sun. We all know that. But these two materials have been in the sun all day long. But if you walked across the beach at about 1 or 2 in the afternoon, you hop across because the sand gets so hot. And then when you jump into the water, it's extremely cold. What that is temperature. Heat is being transferred to both systems. But the temperature in the sand is rising faster than the temperature in the water. That's because they have different specific heats. The temperature is measuring how fast are those sand particles vibrating and how fast the water particles vibrating. Well, everything vibrates different depending on how much heat hits it. So if you've ever poked a stick in a fire, the stick doesn't get hot because it has a lower specific heat. It doesn't vibrate as fast, so the temperature doesn't go up really quick. But if you poke a metal stick in the fire, it gets hot real quick because metals can vibrate faster. So temperature is the measure of the vibrations or the motion in the material that's receiving heat. Heat is the energy you're giving the material. So sometimes you can heat objects and they don't vibrate much faster. Sometimes you can give the same energy to another material and it vibrates faster. So temperature is the measure of the vibrations. Heat is what's going in that causes a change in vibrations, okay? So let's just go back to this idea of kinetic and motion of particles. Remember, we've talked about solid, liquids, and gases, and everything is made up of particles. The kinetic theory is whenever you take atoms or particles and talk about their motion and explain another idea. So right now, I just took the kinetic theory. I drew a picture of all these particles all in an arranged set, and I said, that's a solid. I just explained a solid using the kinetic theory. If I use the kinetic theory to explain a liquid, I would change my picture. I would say the particles are more disarrayed, they're more all over the place. They're not separate everywhere, but they are in more disarray, and they can move around a little bit more freely where these could not. And so a liquid is tightly compact, but with a little bit more freedom. So I use the kinetic theory to explain a liquid. If I explain a gas, I would say very fast motion, lots of movement, kinetic, which means movement, and a lot of space, and moving around and separating and going all directions. So I want to take the kinetic theory and talk about measuring temperature and thermometers. So how does a thermometer work? In a thermometer, we have materials in the old style at the bottom of our glass tube. That's just a chemical compound. It was mercury or alcohol, whatever they put in there, and those particles are vibrating around. If we put those particles, we put that thermometer into a liquid, and let's say that liquid is warm, let's say it's hot water, 100 degrees Celsius, okay? And so we have 100 degrees Celsius, and we're talking about temperatures in a minute and what those scales are. If it's at 100 degrees Celsius, the thermometer, the materials begin to vibrate faster. So the thermometer, liquids vibrate. Well, things that vibrate need more room. Like at a dance, when kids are dancing, they're slow dancing, they're tight together, but as soon as everybody goes fast dancing, the size of the crowd increases. Well, the only place for this liquid to increase when it gets in warmer materials is up the tube. So it expands. So the temperature or thermometer is measuring how fast the particles are moving. And faster moving particles have more room. And so the thermometer goes up. Okay? If I take this thermometer out and now put it in a cold ice bath, so let's say we have some ice in here, okay? So it's down around 0 degrees Celsius. What will happen is these particles that were once moving fast now start moving slower. And so as they start moving slower, they begin to fall down, and as they slow down, they need less room, so the thermometer, the liquid, is vibrating less, and so it takes up less room, kind of like when the kids go to slow dances. They end up moving closer together, the crowd gets smaller. So the temperature is the measure of the speed of the particles. The more speed they have, the more room they need. The less speed they have, the less room they need, and so then we're down near 0 degrees. Okay? And so that's how a thermometer works. It's measuring the temperature based on the vibration. So back here, the heat was shining on both materials, but water doesn't vibrate as fast in the sun, so it doesn't warm up. And so as quickly. And then the beach, however, the sand really quickly vibrates and begins to get hot very fast in the day, so your feet can feel it, and so you notice the difference in temperature. But they were both exposed to the same amount of heat. So temperature is the vibrational or kinetic energy response to heat. Okay? And the last thing I want to talk about is our temperatures. Temperature is just basically something that's been created by man to measure materials. We have degrees Celsius and we have kelvins. These are the two major scientific measurement scales. There is Fahrenheit in America. Fahrenheit is non-scientific. You know it very well, but we don't use it at all in science. And Celsius is all based on water. And water, we know, boils at 100 degrees. And it then freezes at 0 degrees Celsius. So the temperature scale for Celsius was based on these 100 degrees. Then they just keep the markings going up higher to be above 100 or lower to be down in negative temperatures. So if you go to Canada and it's below freezing outside, their thermometers will say -2, -8, because it's below 32 degrees Fahrenheit. Okay? The Kelvin scale, however, is based on energy. And so it's saying when you have a measurement in kelvins, the larger number, let's say we have 373 Kelvin, and there is no degree symbol, but we're going to add it just because it gets confusing for students. There really is no degree symbol there, but it's easy to add so you understand. But 373 versus 273 degrees Kelvin, this has more energy, this has less energy. Okay? And in fact, this is the boiling point of water, and this is the freezing point of water. And so what we've learned and how this was created is they've learned that as you cool things down and they slow down real slow, there's a point which all motion stops. That place where there is no more energy in a material is called 0 degrees Kelvin. And because it looks like the word okay, we add the little extra symbol in, which isn't always 100% correct, but that 0 degrees Kelvin is where there is it's called absolute zero. And absolute zero is a system that has no energy at all. And so it's actually impossible to reach, because anything we use, mechanical, a thermometer, electric, digital thermometer, any of those materials, the moment we get close to absolute zero, the machine shuts off. And because we can't measure it, that's proof it really exists. So, Kelvin temperature is an energy scale. And as you go warmer and warmer, the energy goes higher. So there is nothing colder than absolute zero. And so we use this quite a bit in science. We use it with our mathematics, and you'll need it numerous times throughout the year. And so just to finish off this section, to go between these two temperatures, the magical, or the number we use, is 273. And there is a decimal place, and we don't use that very much. So to go between them, if I want to go 2 kelvins, I have to add 273. If I want to go to Celsius, I have to subtract it. So if I have 373 and I want to know what that temperature is in degrees Celsius, we subtract that number. So minus 273, we get 100 degrees, which is the boiling point of water. The freezing point of water is 273. 273 minus 273 is 0. Okay? So if I want to go backwards, then I would just add 273 to the Celsius numbers, and I would have the Kelvin number. Okay? So Kelvin is an energy scale, Celsius is a water scale. We use this in our labs. It's easy to use, most common, but we can quickly and mathematically change to this scale. Okay? So we've just talked about heat and temperature. We talked about molecular motion and how things move quicker and how motion's involved, and kinetic energy, which is our temperature, and heat is the energy which causes these temperature changes. But remember, not everything goes faster with the same amount of heat. Okay? So we got to be careful on knowing that there's a difference between these two ideas, and we have to know about our 2 different temperature scales. Okay?